Hi guys, my name is Vineet. So in this tutorial we will be writing a program of find leader elements in integer array. So in this program we will be having one integer array with unsorted elements. So like this we will have one integer array and we need to keep iterating the current element and check whether that current element is greater element towards its right elements or not. So here we have 15 and we will be checking whether 15 is greater elements towards its right elements or not. So it's not, because we have 18 greater than 15. So right now our current pointer is at 15, so it will increase by 1, and now we will check whether 18 is greater elements towards its right elements or not. So yeah, it's greater and we are printing 18 here. This is the output, and we are increasing counter by 1 index, and we are checking whether 5 is greater element from its right elements or not. So no, we have it's greater than 3 but not greater than 6, so it's not a leader element. Again we are increasing our current pointer by 1 index, and we are checking whether current pointer value is greater value towards its right elements. So no, it's not, because 6 is greater and 3 is less than 6. So we are again 3 is not a leader element, and we are increasing our pointer by 1, and we are checking whether 6 is greater elements to its left elements or not. So left side we have 2, so 6 is greater than 2, it's true, and we are printing 6 here, and we are increasing our pointer. It reach last index of this array, and we are checking whether this 2 is greater element to its right elements or not. So 2 is the last element, so this is a leader element, and we are printing 2 as output. So this is the finding leader element program. So you can see here we have traversed from index 0 to index last, and we are checking the current element with remaining right elements. So each current element we were checking with the remaining right elements. So the complexity of this program will be order of n square, because we are using here brute force approach. So this approach will not be efficient. We will try to decrease the complexity. We'll use efficient approach to solve this problem. So let's get started with the efficient approach. So will not be returning anything. We will be printing leader element inside this method. So firstly, what we will do, we will be using here one max variable which will be containing the max value of these elements, and that max value will compare with each element whether that max is greater or not. So if we found any max elements that will be greater than the variable that has contained the max element, so we will be replacing that max element to the max variable. So will not iterate this loop from index 0 to index last. Will be iterating from index last to index 0, and will be maintaining the max element. So let's write a code. Max will start from index last. Now we'll loop through this array. Now we are saying, now we are starting from this max. So this max is the last element, and we are saying start from max, start from last index until this I will not reach to 0. So keep decreasing by 1, and inside this we will be checking each element whether the current element, if it is greater than max, then we will be printing here. So we'll be printing here that current element here directly, and so this is the logic, simple logic. And let's write main method and check whether it's working or not. And we have to create one integer array, and so we have element here. We will be using same list here. So let's call this find leader methods. Now let's test whether it's working or not. It should give us 18, 6 and 2. So we are getting 6, 18 and 15. This is the wrong answer. We have done some mistake here. One check should be this is our first check. So if we are at last index, and so this 2 is the leader elements, because we don't have any elements towards its right. So this is a leader element. We have to print this as well. So yeah, we are getting 2, 6, 18 and 15. So we are at 15 index. 15 is not a leader because we have 18 here. So this is not a leader element. So we forget to update something here. Length and max. We are comparing array of current element is greater than max. Oh yes, we forgot to update here max element. So if we are at, suppose we had 6 at 6, we have max as 6, and we are checking whether this next element is greater or not. So 3 is less than 6, 15 is less than 6. Now we are at 18, we are at second last index, and we are checking whether this 18 is greater or less. Right now it is greater than 6, so we have to update max as 18, but we have max as 6. We forgot to update max value. So let's update this one as well. Max is array of I. Now we are seeing wherever you found any greater element, update that value in the max element. Now let's check whether it's working fine or not. So we are getting 2, 6 and 18. 2, 6 and 18. Yeah, we found this leader elements. So our logic is working fine, and so complexity of this program is order of n. So this is an efficient program. We are not using brute force approach here. So that's it from this video, guys. We'll meet in another video with another interesting problem. Thank you so much.